Welcome to another CBA coaching session. This session looks at area calculations, and these are necessary to be able to find or place the upset corner the correct distance from the end of the bar. There are various ways to look at a taper and contrast it to the standard bar or the parent bar from the rack. If all the measurements change, then you don't have a constant. But if there is a constant, and in this case there is because we're staying at 3/4 of an inch width, we can then just work out the area, and the constant, the 3/4, can be taken out of play. The volume or the area of a forging doesn't change significantly even though it changes shape. Certainly some is lost to scale, but most of the material is still there. In the case above, I'm solving for a taper and I'm calling it, or half of it, a triangle and the base a rectangle, and then I'm just going to solve for each and add them together. But I think there are easier methods. The easiest method for me is to actually double the taper up. So in this case I've taken 2 of the taper, and after turning one around end for end, I've stacked them on top of each other. And you can see here that I've got H1, which is the height of the first taper, and I've got the end of the second taper. I add those together and I'm going to solve for this rectangle, but I've got twice as much as I need, so I probably have to divide my answer by 2. Let's have a look at that. Here we go. So I've got H1 plus H2 times the length, divide by 2, and that should give me 1/2 of that equation. My original 1.5 inches per side of the weld allowance here must have stretched because we've drawn this down a little bit. So you can see here my 1 5/8. I'm actually going to call the whole thing 1 3/4. I'm going to call that right down the middle of the scarf here. So what does that mean for us? After stepping out from the center punch mark, so I'm working from the center punch mark, not from the inside edge, not from the corner, but right where I want that inside edge, that center punch mark to be, and I'm going to step all the way around. And I think in my scroll, if I come up here to the constant here where the leaf and the scroll bifurcate, then I get something like 12.5 inches. And I'm going to subtract from that weld that I've just said was 1 3/4 inches. So let's see what that looks like. Let's talk generically first. I've got the height 1 plus height 2 times the length, and then divided by 2 to give me the area that I need. And then I'm going to contrast that to the parent bar that I've got off the rack. I know the height of the parent bar, it's 1/2 inch. What I don't know is how long a bar do I need. So I'm going to have to manipulate this to see what I can get. I've got the height, it's 1/2 inch. What I don't know is the length of the bar. So I would like to solve for this and get rid of this. Let's see what I can do. If I divide what is known by what is known, then that becomes a 0, and I'm just left with what is unknown. But then my equation no longer balances. So what I do to one side, I must do to the other side. Let's plug in some numbers here. We know that the bar is 1/2 inch thick, and we're going to divide by 1/2 inch thick. That's going to give us 0. But whatever we do to one side, there's my 0, leaving me with the parent bar. Whatever I do to one side, I have to do to the other side. And now I need to solve this equation. Let's plug in some numbers. So at this stage, I've got rid of everything that was known and left with the unknown portion. And whatever I did to this side, I must do again to the other side of the equation to keep the equation balanced. I'm going to call the stock thickness here where this weld is going to take place 5/16 of an inch thick, and that's right here. The complete scroll from the center of the corner to the end, right here with the leaf and the scroll tip bifurcate, measures on my drawing 12.5 inches. So there's my 5/16 of an inch thick. Here's my complete scroll, and measuring from my center punch mark in the middle of my upset corner, I get 12.5 inches all the way up to this stop point where the bifurcation takes place. I'm going to subtract what I know of the weld, and we said it's going to be 1 3/4 inches long. And so what I should be left with is subtracting the 1 3/4 inches from the 12.5 to give me the remainder of that scroll, and that is a taper from 1/2 inch down to 5/16. Here's what we know. We've got 12.5 inches of scroll length overall, minus the 1 3/4 inches of the weld that we completed on the leaf and scroll tip assembly, leaving us with 10 3/4 inch length of material for the taper. The taper is 1/2 inch thick at one side, tapering down to 5/16 of an inch thick at the other side. So let's have a look at some numbers. I've got my 1/2 inch thick bar tapering down to 5/16 of an inch, and I'm going to add those two bits together. I've got my total length of scroll minus what I've already welded, so I'm going to work out that bit. That's going to balance against what I know of the parent bar, what I don't know of the parent bar. So I'm going to divide what I know by what I know, and that's going to get 0. But what I do to one side, I must do to the other. So let's have a look at that. I've got 0.8125 times 10.75 divided by 2 times 1/2. Taking that a step further, what I get is 8.734. So that to me is 8 3/4 inch of parent bar. But that's from the center punch mark in the middle of the corner, don't forget. What this doesn't take into account is a chamfering of the corners of the taper, and that can be significant. So I'm going to subtract 1/8 of an inch from that, making it 8 5/8, and hopefully I'm going to make that work. If I reach my target length of 12.5 before I've chamfered the corners, I'm going to make the chamfer with the hot rasp. And if I get, I've chamfered the corners and I still shy of a little material, it's in there somewhere. I know it's in, so I just got to find it. That's the end of this particular coaching session. Please subscribe to the channel by clicking on that round button there to the right. And if you want to get on to the next video in the series, click that rectangular button there to the left. Thanks for watching, and I'll catch you on the next one.